All right. Here, let's look at these problems. It says the amount of freight transported by rail in the United States was about 680 billion tons in 1980 and has been increasing at a rate of 3% per year since then. Write a function representing the amount of freight. So we're not actually going to come up with a number. We're going to come up with a function. So let's say in terms of t. So f of t is equal to, now remember our general form is a 1 plus the rate, and then we have a variable up here. So I'm going to use t since we're talking about time. Alright, now we started out with 680 billion, so that's going to be our a value. Okay, then it's going to be 1. Now if it's an increase, it's going to be plus. If it's a decrease, we would subtract. But it's an increase, so it's going to be plus. Now our rate here, we have to convert to a decimal, so that's going to be 0.03. And then the number of years, t. So for the function, we should have something like this. F of t is equal to 680. And then we're going to add this together times 1.03 to the t. So what we could do is plug in any number of years into here and see how much the freight has increased as we've gone. But this would be the answer for number 1. Alright, for the number 2 here, was a population question. Now, it says in 2000 our population was 6.1 billion. Okay, so that's what we started out with. And it increases at a rate of 1.4, so we're going to convert that to a decimal. So that's going to be 0.014. It says estimate the world's population in 2015. Alright, so let's come up with a function. F of t is equal to what we started out with, which is 6.1. Okay, 1 now is it going to be plus or minus? It's going to be plus because we're increasing. Okay, and then t is the number of years. I'm going to go ahead and clean this up, and then we'll plug it in the calculator and see what we should come up with. So 6.1 times 1.014 to the t, and that would be our function. Now, to come up with how much the population should be, we would take is 2000 from 2020 to 2015. Take the difference, and that's going to give us 15 years. So t is 15. So we'll substitute in 15 for t here. Alright, so we're going to end up with a function of 7.5 as what we're going to have. I just rounded to 1 decimal place since we started out with that. So the population in 2015 should be 7.5 billion based off of this model of this. Alright, in question 3, we bought a new car for $30,000. It depreciated, so that's going to be a decrease. So we're going to have a 1 minus r. It's going to decrease. This is what we started out with, the value of the car, and then our rate is 20%. So we're going to move it over 2 places, so it's going to be 0.2. So it says write a function. Now, we're actually looking for the value, but since I'm going to use t for the number of years, I'm just going to use f of t. Now, you could use y. Same difference. F of t just tells us that it is a function. Alright, but anyway. So f of t is going to be equal to $30,000, which is what we started out with, times 1 minus our rate, which is 0.2, to however many years. So $30,000 times 0.8 to the t value would be the function of this. But the question asks, what's it worth in 5 years? So we'll place in 5 for t. Alright, and so after 5 years, our 30,000 car is now worth $9,830.40. So it's not worth nearly as much as it was when we bought it. Alright, let's look at question 4. 4 and 5 go together. Okay, it says from 2000 to 2010, the population growth increased at a rate of 12% per year for Gotham. Okay, so this is our rate. We're going to move it over 2 places. So R is equal to 0.12. Okay, if the population of Gotham was 3 million in 2000, so 3 million, okay, is going to be our A value. Write a function representing the population growth. Alright, so I'm going to use Y this time. We could use f of t or function notation, but 3, okay, then we get 1 minus 0.12. Sorry, it's increasing, so it's plus to the t value. So we'll end up adding those together, and so our function would look like this. 3 times 1.12 to the t, or we could have other variables, but I'm just substituting in t. Could have x, but our function should look like this. Then the next question builds off of that. It says, well, if that's the case and it continues at the same rate, what would be the population by 2015? Well, from 2000 to 2015 is 15 years. So it's going to be 2015 minus 2000. Okay, so it's 15 years, which is our t value. So we're going to plug in 15 here. So it's going to be 3 times 1.12 to the 15th power. Alright, so the city should have approximately 16.4. Probably I would have rounded just to 16, but if you have 16.4 or something, you're okay. Normally we only round to however many decimal places we had here, and since we didn't have any here, I'd probably left it at 16. But as long as you're around 16.4 or 16, that's good for this. But that's how you would handle these types of problems.